We are now looking at part two of our factors and zeros lesson. In this one, we will be looking at the different forms of polynomials and doing some relating between standard form and factored form, which you should remember from dealing with quadratics last semester as well. So by the end of this lesson, we're going to be trying to identify the features of polynomials and their graphs using both of those forms that I just mentioned. So take a moment to consider choices A through D here of which one of these functions does not belong with the other three. Now, there's no wrong answer or right answer here per se, but you can make a case for two different of them, I think. So one case you can make is that choice A is the only one in factored form. So that would be a way that it could be sticking out from the other three. That's one answer you could have thought of. Another answer is that choice D might be the one that is sticking out to you. Choices A, B, and C are all quadratics, which have degree 2. And if you multiplied out the factored form of choice A right here, that would end up being the quadratic as well. So that's kind of two different ways you could interpret this same problem here. We're going to be looking at a Desmos graph of this situation in a second, but let's kind of look through what is going on with it first. So for starters, we have f of x and g of x up at the top. They're both factored versions of a polynomial. And if you are looking at both of these in the same window, we're going to be looking at how the graphs are the same and how are they different. We're looking at also at rewriting them in standard form to see what kind of degree they have or what is the biggest exponent when you're in standard form. And then lastly, we'll look at h of x, and we're going to try to think about how h of x is going to be changing, and we're also going to look kind of a slider to go along with h of x as well. So let's, for starters, go to our Desmos page and look at number 1, and we're looking at f of x and g of x and seeing how different they are. So we have f of x in red and g of x in green, and we see our domain and range are set up. So if you're unsure how to do that in Desmos, what you can do, if you go down here to x-axis, you can kind of type in whatever you want to use. Negative 10 to 10 and negative 100 to 100 is what we talked about before. And you can see that that is what our slide was talking about. So if you look at comparing and contrasting these graphs, so if we look at these graphs, well, we have so think about what you would say to that first. But if we were to discuss that right now, the red one we can see is kind of pointing down on the left and up on the right. Same goes for the green one. Secondly, well, we have a x-intercept here at -3, 2, and 7. So that makes a lot of sense. If you look at the factors and you think about what we discussed in part 1, well, the x-intercepts are our zeros from each of those factors would be -3, 2, and 7. So we have the 2 from this parentheses, and we have x plus 3, making -3 from this one, and then the positive 7 from the third parentheses. So that kind of finishes up how they're similar. So they also both have 3 factors total, 3 parentheses. We can see that they have different y-intercepts, 0, 21 and 0, 42. And we can see that their local minimums and maximums here at these points are local maximums, and then we have local minimums. Our green g of x has smaller values compared to our red f of x. Now, if we kind of skip to number 3, if we have h of x now, if you are changing the a value in the front, like if I changed it to 2, we can see that we are basically dilating these functions while keeping this x-intercepts the same. And that we're not changing what these factors are, we're just kind of multiplying out something through just kind of the first one. So if I made this into just a 2 right here, I could change that, get rid of that 2, and multiply it into the first part here, make it like that, and it's kind of the same thing. And we can kind of change it back to being the a value, and you kind of see how it ended up what we just looked at. So an a value in the front or an a value in one of these factors would cause it to dilate or flip upside down if you go to negative numbers, and you can see how it kind of dilates further and further as you go. So that dilation happens in polynomials just as it did with other types of functions that you've learned about in the past. Now, if we go back to our slides, number 2 asked, what degree do these polynomials have? Rewrite each expression in standard form. So we only really need to do one of them. So let's do that here. We can kind of multiply out these, and it depends on how you want to do it. Like you could just do arrows like x times x and x times 3, and then -2 times x and -2 times 3. So I would multiply these two parentheses together, and the answer that you should get after doing that is x squared plus 1x minus 6. And then we still have that being multiplied by x minus 7. So now we're doing 3 things times 2 things. You generally want to use kind of like the box area method to make it a little bit organized and a little bit easier to get right every time. But if you were to kind of go through that, so try multiplying these 3 times 2, and we'll go over the answer in just a few seconds. We now have the answer ends up being x cubed minus 6x squared minus 13x plus 42. So the degree of this particular polynomial would be a 3. You can see it's in standard form going from biggest exponent to no exponent at all. The biggest number would be a 3, and that makes it a cubic polynomial, which that is what you'd call a degree 3 polynomial. And the other g of x function would, since that has that 1/2 on the front, we basically could think of it as this whole answer being multiplied by 1/2. And then you kind of would just multiply across by 1/2. The degree itself would be the same, and that's why they have so many similarities to their graphs in general. So that kind of wraps up our spot the differences part of this lesson. So we can move forward. So some important things to note on this page here. So we have a factored form of this cubic polynomial, this degree 3 polynomial. So first question, where can you see the 240 in the factored form of the equation in the graph? So from standard form, we know that the last number right here is always the y-intercept, because x and x and x would be 0, leaving us 240. If you think about where that is in this factored form, if you multiplied out 4 by -6 and then multiply that by -10, you get positive 240. So those ending numbers in each factor would give you this, unless you have a number in the front, like if this was a 4 up here, well then you would do 4 times -6 times -10. Number 2 asks, which form do you think is better? I personally think that graphing something with factored form, especially polynomials, is much easier to do by hand and to understand what's happening in the graph. Standard form is really only easiest to see the y-intercept, which is not really that big of a deal. So I personally would say factored form, but that does not necessarily mean that would be what everyone would say. And then lastly, basically the g of x is a polynomial with the same zeros in degree with a vertical intercept or y-intercept of 120. So that would just mean that we have a kind of a value multiplied at the front, thinking back to an earlier slide. So g of x would be the same thing, but we would basically be multiplying by 1/2 at the front. And so that would mean that this y-intercept would be half as big, or 120, like you see right here. And that would be kind of the main things that, so some other things to note is that we're getting x-intercepts from each factor. So that -4 and then 3 and 10 are coming from each factor being set equal to 0. The y-intercept is whatever a value you have at the front, or if you don't have one at all, it's basically the second part of each factor being multiplied together to give you your y-intercept. And those are x-intercepts and y-intercepts are both very important when you're trying to sketch a graph or to understand what the graph might look like in general. And so last we have kind of an exit ticket sort of thing, a review problem of what we just covered. So we have a polynomial x plus 6 plus 3 and x minus 5. So why don't you take a second to answer number 1 and number 2, and we will look at those answers together in just a little bit. We have the answers now. So for number 1, if you multiply x plus 6 and x plus 3 together, you get x squared plus 9x plus 18. And then you're multiplying that answer by x minus 5 if you go left to right. And the answer you had gotten from multiplying those together would be x cubed plus 4x squared minus 27x minus 90. And that would be the equivalent standard form polynomial to the factored one we started with, which was p of x. The degree of this blue standard form equation would be 3. It's written in standard form, so the highest exponent, it would be the 3 above the first x you see. The constant term is negative 90. And remember that negative 90 ends up being your y-intercept. And we got our x-intercepts from this function earlier. And that is going to complete our part 2 of our factors and zeros lesson. Next time in part 3, we're going to be looking at how we can use factors and zeros towards graphing and more further understanding of polynomials in general. Thank you for watching.